Okay, this is chapter 8 on the wave nature of light. We'll look at interference, single slit diffraction, double slit diffraction, and diffraction grating. So the first, interference is a property of all waves. That includes, mechanical waves, like you might have in the ocean, water waves, waves on a string, what have you. Also, we see this in sound waves. And this was known during the time that Thomas Young was studying the property of interference in electromagnetic radiation. So we also see it in light as well. And that was part of the reason that he determined that light was a wave, because it demonstrated interference. It occurs when two or more waves come together. Now we have two types of interference. We have constructive interference. Constructive interference occurs when the peaks of the wave, or when the peak, rather, of a wave lines up with the peak of another wave. We then call the waves to be in phase. They are completely in phase. This is an example of constructive interference. Here I have two waves. Notice that their peaks line up, and when they add up, they produce a wave that has twice the amplitude of the original wave. So they have the same frequency, but they have an amplitude that is equal to this amplitude plus this amplitude. Now, on the other hand, destructive interference occurs when the peaks of a wave line up with the troughs of another wave, and then we call the two waves to be out of phase, or completely out of phase. So you can have waves that are in phase or out of phase, and then you can also have in between. We'll get into that. Right, so destructive interference here, as you might guess, we're just going to get nothing at all. So where a peak lines up with a trough, we'll call this an amplitude of plus A, and this an amplitude down here of minus A. When those add up, you just get a net amplitude of 0. All right, for interference to occur in light waves, two criteria must be met. The two waves must have identical wavelengths. And this is actually not for interference. You can have interference occur between waves of different wavelengths, but in order for total destructive or total constructive interference to occur, they have to have identical wavelengths. So this is the distance for one full cycle in the wave. And so, for example, one wavelength, this is not one wavelength, but one full cycle, for example, would be something like this. This is one wavelength. You could also draw this from different parts. So let's say I could go from here to here. That would also be one wavelength. Similarly, I could go from here to here. One full cycle, starting at one point, coming down, and coming back to the same point. Also, the light sources must be coherent. And coherent simply means that the phase of the wave doesn't change. Show you a figure what this means. So if I look here, this phase of the wave describes the position of the waves, or the fraction of a wave cycle that is elapsed from an arbitrary point. So these two waves are said to be in phase. But for example, if I drew another wave that was offset from them, then those waves would be not in phase. And when I say that the phase of a wave doesn't change, that's to say that I have this wave, it's not going to move around in either direction. So at some point, it's going to look like this, at the next point it'll look the same, that the phase will remain the same. The relative position of the peaks and the troughs, or not the relative, but the absolute position of the peaks and the troughs will remain the same. It doesn't move around in space. Right. We will come back to this and talk about phases and waves being in and out of phase.